Hey class, welcome back. This is part 3, taking a look at using Sturge's method to determine the optimal number of classes and class width. So we had looked at, in the last unit, subsection, determining the number and sizes of the classes in constructing tables. And we talked about how to do this intuitively, just by looking at the numbers and how we feel about the numbers and so on. But Sturge's method is a good idea to, especially when you don't have a good feel for the numbers, as well as a good check on this. So let's go. Last day we took a look at this example right here. Here, let me change colors here. So how about purple now? So we did this one last day. So let's continue on here and take a look then at some problems here. So use Sturge's method and then intuitively adjust it afterwards to figure out the optimal class sizes for the ages of the 50 people. Now remember, intuitively we said, well, I'd probably put it in groups of 10s. So let's see what Sturge's method tells us about that. So this is page G5, number 1. So according to Sturge's method then, we've got the optimal number of classes, and sorry for the writing, it's kind of hard when you're writing on glass, is equal to 1 plus 3.33 times the log of base 10 of n. And our n in this particular case is that there's 50 numbers here. So it's the log of base 10 of 50. So that's going to be 1 plus 3.33, and this is where you'll get out your calculator. But I've also got these numbers just shown here. So log of 50 is 1.7. So that's 1.70. Remember, you multiply the 3.33 times the 1.70 first, and then you add the 1 at the end. And so that gives us an answer here of, looks like about 6.66-ish. All right, so it's going to be around 7 classes, but what we want to do then is to look at the optimal class width is going to be the range, which is the high minus the low, over the optimal number of classes. So these are already in order, so we've got 97 minus 14 divided by 6.66. And what do we get here? Is we get 12.46. So that's the optimal class width. And it says that we should have about 6 to 7 classes of width 12. Now we would look at this and say, yeah, what we're going to do is we're going to actually round that down to 10s. So it's going to be about maybe 7 or 8 classes of width 10. Whoops, sorry about that. And when we get to constructing the table a little bit later, this is what we'll do, is we'll put in classes that go like this. So 0 to 9, 10 to 19, and 20 to 29, 30 to 39, and so on. So this will be the class. And then we'll come up with the frequency. And so that's an F, a frequency. And the frequency is just the count. So how many fall in the 0 to 9? 0. There's 1 here, there's 1 here, there's 1 here. There's 2 in the next one. There's, I think, 7 in the next one, 10, 12, and so on like that. So there's 2 in the 40s. And then there's 7 in the 50s. Just count them up here. So we've got 1, 2, 3, 4, 5, 6, 7, and so on like that. And they will sum up in the end to 50, which is our n. Okay? All right, let's take a look at the next one. And hopefully you've worked through this one. If you haven't, you might want to stop the video at this point before I continue on through here. And so this is taking a look at the midterm marks of 50 students. So our N is still 50 here. And so we're going to come up with the optimal number of classes is going to be equal to 1 plus 3.33 times the log base 10 of 50, which is our N. And we've already calculated that above. It's the same N, so that comes to 6.66. And then we're going to go with the optimal width is going to be equal to the high. Let me just put down H minus L over the optimal number of classes. And that's going to be, these are also in order, so it's going to be 90 minus 34 over 6.66. And that comes to, what do we got here? 8.41. Now, this is also where I would say, 8 is close enough to 10, so we're going to go with classes of 10 apiece. I would look at this and say the first number is 30, so I'm going to go 30 to 39, and then 40 to 49, and so on like that, 50 to 59, and all the way down. So there's my class. My frequencies is where I just count them. So I've got 130, so it's 1, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 of the 40s, and then 50s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 it looks like, and all the way down, and actually I'll end up with 50 again, which is our N. Okay. All right, C, I'm going to actually do that one in class. So why don't you wait for that particular one? Do it yourself, of course, and see what you get. And then we're going to do D. So let's continue on here for D. These are the net sales of the top 30 Canadian publicly traded technology firms. This is in millions of dollars. These data are actually in order as well. It goes from the highest to the lowest in this particular case here. So let's go then with the optimal number of classes is going to be equal to 1 plus 3.33 times the log base 10 of, how many are there of those guys? There's 30 of them. 1, 2, 3, 4, 5, 6 times 5. Yeah, there's 30 of them. So that's going to be 1 plus 3.33 times, and then I'm just going to go back some pages here. And again, your calculator should show you this. Here's the log of 30 right here. So it's 1.48. All right, and then multiplication comes before addition, so 3.33 times 1.48, and then add a 1, and you're going to get 5.928, 284, is that a 4? That's something anyways. And now we're going to come up with the width, the optimal width. Is going to be your high minus your low. That's your range over the number of classes is 12,381 minus 72 over 5.928 yada yada. And that comes to 2,076.23. And so I would look at that and say, well, I'm going to round that to probably 2,000. That's intuitively better. Now, here's the problem with that. How many actually fall in the first class? Almost all of them. Take a look here. All of those guys fall in the first class. We're going to talk about that problem in a bit here. So let's just hang on to that one. All right, these are the gender of Fosa club members. And in data set number 3, 1 means, I think, male, and 2 means female. Actually, let me just show you where you can get that data from. So all the way at the end here, all the way through Unit G. And then you've got these data sets here. So you've got, here's our ages of 50 people, our midterm marks. We've worked through those problems here. And these are the Fosa, Friends of Statistics Association, club members. Doesn't really exist, I wish it did. So here we've got the gender, 1 is equal to male and 2 is equal to female. We don't have any others in this particular example. And so there's that. And then there's a few others here. Business 111 students, some personal data. In fact, this is really similar here then to yeah, this is actually, I think, the Stats 101 data, similar to that. And then we've got Business 306, some personal data, and we'll take a look at that later. Top 30 Canadian publicly traded data sets, and then we've got real estate data here. And then here's additional problems here. Page 33 on. And then we've got actually the solutions for those. So the expectation is that you work through them. See how we're using Sturgis method here? Okay, let me just erase that. So that takes us to the end of the unit. That's how the unit is set up. Right there. Okay. All right, let's go back here to, where were we, about page 21 or something, I think it was. A little further. All right, so we're taking a look at the gender of Fosa club members. And so if we use Sturgis method, we would have the optimal number of classes is equal to 1 plus 3.33 times the log base 10 of, and I think that is, there's 30 of them, just like above. And so that's going to be 5.928, which we've calculated before. And then we can come up with the optimal class width, which is going to be the high minus the low, so 2 minus 1 divided by 5.928, and that's going to come to 0.17. So you should have class widths of about 0.17. Now, I'm hoping you look at this and you say, well, what the Frodo? Like, what does that mean? I mean, all we've got is 1s and 2s. Why wouldn't you just simply do it this way? Here's your class. How many males do we got? How many females? So the males are 1 and the females are 2. And then what are their frequencies? And then you would put a number for each one. That's exactly what you would do. So the whole point here is that Sturgis method works fine when you're dealing with lots of numbers with lots of different values. But when you're talking about where you only have 1s and 2s, all you do is you count them up. So we wouldn't use Sturgis method for this. Let's take a look at the movie ratings of Business 111 students. So that comes from a data set at the very end here. So we would say here then the optimal number of classes is equal to, what do we got here? 1 plus 3.33 times the log base 10 of 80. By the way, the stars here represent blank values, or where people didn't actually answer the question. So in a data set, they'd either be shown as stars or it'd actually be blank there. All right, so there's 82 in total, including the stars, but those are 2 missing values, so it comes to 80. So let's go back here. And here we've got the number that we're looking for is 1.90, which is the log of 80. All right, so we've got 1 plus 3.33 times the log, times 1.90, right? And then multiply 3.33 times 1.90, add 1, and you will get 7.327. Then we would say the optimal width is equal to the high minus the low over the number of classes. So that's going to be, if you take a look at here, the highest is 10 and the lowest is 4. You'd have to do a sort or take a look through all the numbers there, but that's what you'll have, over 7.327, and that comes to about 0.82. Now, what this tells me here then is that we should have classes of width 1. And again, you might look at this and say, well, duh, isn't that obvious? I mean, why wouldn't you do it this way? Well, you've got the class, and you'd say how many, I guess there's no zeros, how many 1s, how many 2s, 3s, 4s, all the way down to 10s do we have? And you've got 0, 0, 0, and then I'm not sure how many 4s there are in there. Is there a couple? So there's at least 3, 4, 5. Anyways, you would count down like that. That number might be wrong, by the way. Okay, so when I take a look at this, I say, isn't it obvious that we should just have classes of 1 to 10 and count up how many there are? And the answer is yes. The only thing that Sturge's method does in terms of this is to tell you that there's the class width should be 1 instead of something like 2 or something like that, okay? So there's very little value of that. I would just intuitively look at this and say, hey, the numbers go from 1 to 10, or in this case 4 to 10, so we would just have the classes as those numbers and come up with that. By the way, I'm not sure how many 4s there are. That was just kind of a guess, but there might be more than that. All right, so Sturge's method, very little value here. What's the problem in using the range to calculate the optimal class width? Think about that for a second. Well, the problem is when the data are skewed, and we're going to see what the word skewed means in Unit C by outliers. Then the widths can be large, can be too large. So let's take a look here then at this example right here. And here's where we've got numbers which, remember when we did Sturge's method, we found out that our class width should be 2,000. And so just about all of them fall in the first class there. And then only one in the next, and then you got to jump a few. And that's because you've got some outliers here. In fact, you've got probably 4 outliers. Some might even argue 5 numbers, which are a lot higher than the rest. So the better thing to do here then is you would actually start here, or you could even start here, because after that they start to get really close to each other. There's still 500 difference between these ones, but if you started there and calculate Sturge's method where this is the highest value, and of course this number would change, right? You'd have to take off 1, 2, 3, 4, 5, so that would be 25. then you'd end up with a much better answer here. And then the way that you would do that is you would have class widths which are much smaller. They might be, say, a couple of hundred or even less in that particular case. And you would put all of those 25 numbers into a class, and then you would just have a note at the bottom that says, and there's 5 outliers, and actually list them. And here are the 5 outliers, and just put them down. Okay? So that's the better way of handling that kind of data. Otherwise, you've got just about everybody in the first class. I'll give you another example which we'll bring up in Unit C, and that is, suppose we're talking about the incomes of the students in our class. How much money did you make in the last year? And suppose for some reason Bill Gates decides to take this stats class. I don't know why he would, but it would be kind of cool to have him in class. Do you know how much Bill Gates makes a year? It's about $2 billion or so. And so what you would have here then is, using Sturge's method, you would have 2 billion minus probably 0, because some of you didn't make any money last year, right? Divided by whatever the optimal number of classes turns out to be with 40 students. So, right, that might be around 6 or something like that. And so you would end up then with class widths of several $100,000 each. And if you were to make a table, you would end up with 39 people in the first class, and then frequencies of 0, 0, 0, 0, 0, 0, 0, all the way up to the last one, which is Bill Gates' class, which has 1 person in it. So again, that is an outlier. You would knock him out, and then you would calculate the number of classes differently. And then you just note him as an outlier. And I think that's where we're going to end today. The next time, we're going to take a look at determining class boundaries and class marks and building the rest of the table.